Hi Calculus, we are going to do our big FRQ on our rate in, rate out topic. It's one of my favorite FRQ topics, typically calculator active. So let's read the prototype here. It says let E of t be a rate function of a quantity entering, so coming in. Let L of t be a rate function of a quantity leaving, so that's our rate out. Note that units on both these functions will be something per unit of time, like pounds per hour. At t equals 0, let there be x units of the quantity. So we're going to assume that we start with x units, and then we're given our rate in as E of t and our rate out as L of t. All right, let's read part A. It says, how fast is the quantity coming in at t equals a? Well, what answers the question, how fast? The derivative, right. Notice, though, that E of t and L of t are already derivative functions, right? They're already rate functions. They will already have units of something per unit of time, okay? So for how fast is the quantity coming in, we're just going to take E of t and evaluate it at a, okay? And again, the units will be something per unit of time there. Part B, how fast is the quantity leaving? Again, you have the rate function for rate out, so you're just going to take that function and evaluate it at time t equals a. Part C, is the amount of the quantity increasing or decreasing at t equals a? Well, for part C, you're going to just compare E of a and L of a. So if your rate in is larger than your rate out, that means your quantity is coming in faster than it's leaving. So your amount would be increasing. So let's write that, increasing. If which rate is larger? If your rate in is greater than your rate out. Conversely, our quantity will be decreasing if that amount is leaving faster than it's coming in. So if your rate in is smaller than your rate out, and you literally just compare those two numbers. Okay, part D. It says explain E prime of A using correct units in the context of the problem. So we're just going to go back to our template of explaining a derivative in the context of the problem. Just be careful because E of t is a rate function, right? So if I take the derivative of that, I should be seeing the word rate how many times in my sentence? I should be seeing it twice. So we are going to use our template. So we're going to go at time t equals a. Don't forget your units of time there. And then you're going to restate what E of t is. So the rate at which whatever the quantity is entering is, and then you're going to choose increasing or decreasing depending on what the sign of E prime of A is. And then at a rate of, and then take the absolute value of your answer because you've already stated the sign with your increasing, decreasing. You don't want to say decreasing at a negative value. And then don't forget units. And your units this time, since we started with something over time, it'll be something over time squared. So once again, how many times do you see the word rate in our sentence? Should see it twice, and then I should have 2 units of time there in the denominator. Awesome. So similarly, for L prime of B, it'll be at t equals b in this case. Don't forget units there. And then we're going to restate what L of t is, which is the rate at which our quantity is leaving is, and then you'll do increasing or decreasing depending on your sign, at a rate of absolute value of your answer and again your units there, which will be something per time squared. Once again, I see the word rate twice. I should have 2 units of time in the denominator. If this is calculator active, this would be like a math 8 type of question, okay? All right, part F, what's the rate of change of the quantity at time t equals a? So what is your rate in? Your rate in is E of t, and what is your rate out? Your rate out is L of t. And so my total rate needs to be my rate in minus my rate out. Okay, that is the derivative of our quantity evaluated at time t equals a. Part G, how much of the quantity entered from time t equals a to t equals b? What answers the question how much? That'll be the integral. So here I want the integral from time t equals a to time t equals b, but just how much entered, so we'll integrate e of t. Similarly for part H, how much of the quantity left from time t equals a to time t equals b? That'll be the integral from a to b of L of t dt. Part I, how much of the quantity exists at time t equals a? Well, I need to first take how much we started with. This is like FTC rearranged, which at the very top of the intro to the prototype, you'll see that we are assuming that we start with x units at time t equals 0. So I start with that. Then I want to add how much came in from time 0 to a. So that would be the integral from 0 to a of e of t. And I would need to subtract out how much left from time 0 to a. Okay, now if your limits of integration are the same, like mine are, 0 to a, 0 to a, we can combine those two integrals if we'd like. So for this one, we can go whatever we started with plus the integral from 0 to a of e of t minus L of t dt. And most of the time, your two functions will have the same time interval that they are valid for. Sometimes they don't, though. So if not, just make sure you use two separate integrals. You can always use two separate integrals. But most of the time, if you'd like, you can just combine those two integrands into one, as long as your limits of integration match for both integrals. All right, last one, part J. At what time is the amount of the quantity a min or a max from time t equals a to time t equals b? Do we know what theorem this is? This is EVT, extreme value theorem. So we know that we are guaranteed a min and a max if we're on a closed interval, which we are, a to b, and if we are dealing with a continuous function, which we are going to assume that we are, okay? So when we want to find an absolute min or max, what do? We make a table, okay? And what do we put on the left side of that table? We put our critical points and our endpoints. And how do we find critical points? To find critical points, we take our derivative and see where it's 0 or undefined. And our derivative is our rate, right? So I'm going to come back here. My derivative, or my rate, is e of t minus L of t. So to find first we're going to find critical points. So to do that, we need to take the rate, e of t minus L of t, and set it equal to 0, right? But notice if I add L of t to both sides, this is the same as saying e of t is equal to L of t. So that's typically where I start. I take my rate in and set it equal to my rate out. And what we're going to do is, again, if it's calculator active, you are going to put e of t into y1, L of t into y2, and find the intersections on that interval, a to b. Okay, so let's say that they intersect twice between a and b. Let's call those intersections t, or x equals c, and x equals d. Okay, you might have just one, maybe you'll have three, but we're going to assume we have two here. Now, what do we do next? We make our table. So here's my time. I need to check my endpoints, which is a and b, and any critical points between a and b. So again, we're going to call those c and d. Okay. Now I need to know how much of the quantity exists at each of those times. So refer back to the part we just did, part I. So the amount that we'll have for each will be what I started with, x, plus the integral and I'm going to combine those integrands from 0 to whatever time I'm checking of e of x minus L of x dx, right? So if I want to find how much time, if I want to find how much of the quantity exists at t equals a, I will come here and I'm going to go in my calculator x plus integral from 0 to a, and then y1 minus y2 dx, enter. Okay, then I'm going to do the same thing, and literally all I'm going to change is that number there. All right, okay, that is it. We will practice. We will practice some more in class.